Well, this is Barbara Dill, and I have just created a short slide presentation that explains a systematic way to understand multi-axis spindle turning. I believe it's a pathway to creativity, and this information has certainly helped me along the way to be able to create forms and objects that are a lot of fun. So I started turning in 1990, and soon after that started noticing multi-axis work, and I was quite intrigued with it. So my first multi-axis spindle is this one. It was turned around 1994 or 95, and I started with a rectangular piece of wood. The first axis is very, extreme, because I thought the axes had to be separated quite a bit in order to make something that looked interesting. So there's a sketch of the rectangular piece of wood I started with. The next axis is that line. And I do admit that I had to cut away some of that wood so I could not endanger my fingers when I was turning the second axis. I learned from that these axes don't need to be separated quite so far in order to make interesting pieces. Also in the 90s, since I am from Tennessee, I would go to Tennessee and go to their symposiums, and I noticed people were making split turnings. I was intrigued by that, and they're actually a form of multi-axis turning, just done all together. Back in the day, though, people were creating wooden forms that they put the ends of these square pieces in and then put those forms between centers. They centered them and turned all four sides. Because I was just beginning to work with wood and I wasn't really a jig maker, I didn't explore that area very much after that until the 2000s. So in the 90s, I did struggle to understand this type of turning. I kept making hundreds of forms, but I eventually got bored and frustrated by running into walls because I didn't know what to do next, because I didn't know how to think about it. I kept thinking that these forms must have something in common, but I had no idea what it was. Here's some samples of my work in the 90s. They represent random axis changes. I'll take the spindle on the left. I'll talk about that one. It's made out of walnut. It was probably 2 inches square by 7 or 8 inches tall. So of course I made it into a circle, turned it into a circle, and then I changed the axis randomly, and there's the axis of the bottom segment. And then I would decide how long I wanted that segment of this axis to be. I would turn down to the solid wood and create a cylinder, and then I would create a profile on that. Then I would change the axis and move up the spindle to the next axis. And I do the same thing. I decide how long I wanted that axis segment to be. I'd go down to the solid wood, create, in this case, another bead on that solid wood, and on and on. Most of my early work involved twisted axes and circular outcomes. Some of them, the two next to the one I just showed you, have archetype, but I had no idea what that was or what it meant. So it turns out that there is a simple way to understand this confusing way of turning wood. One is that there are only two results, or outcomes that occur when you're turning a new axis. You either go all the way to the new solid wood and create a circular type, or you cut your profile into the air wood and those arcs intersect, creating what I call an archetype. And I'll explain all these in more detail. There are only two ways that the new axis can be moved relative to the center axis. It's going to be either parallel to that center axis or not parallel, meaning twisted, or it looks twisted. And there are many variables that apply to each type of spindle that is turned. As you'll see in a minute, these 4 areas create quadrants or 4 specific families of spindles, and these variables apply to all of those quadrants. Here's an example of what I mean. In this picture, this spindle is put between centers on a parallel axis, and I've turned through the air wood and gotten to the solid wood, and you can create a cylinder there and make a profile on it, or just that represents a circular outcome. An archetype is turned when you don't go all the way to the solid wood, but you cut your profile into the air wood, and then as you change the axes, these profiles intersect. Here is an example of what this looks like when it's being turned. And when I start the video, this will represent the air wood, and the blue line will show you the solid wood. So let's look at archetypes. Archetypes occur when the new profile is cut into the air wood or ghost wood, never reaching the solid wood. There are two types. You can have a parallel archetype or a twisted archetype. Here's a drawing of if you cut them in half, the intersecting profiles would look like lenses or arcs intersecting with each other. That creates the lines that go up and down. Here's the way it looks on a circular spindle. The arrow represents the new axis, and it's turning into the air wood, not deeply enough to go to the solid wood. Now, circular types, like I said, you have to cut through the air wood, get to the solid wood on the new cylinder, and create a profile. And there are also two types. That's twisted, and that one's parallel. These are circular types. Here's an example of what happens. Here's the new axis placement. We're cutting through the air wood and getting to that cylinder. And the size of that cylinder depends on the distance that axis is from the outside of the spindle. That red arrow represents that radius. There are only two ways that the new axis can be moved relative to the center axis: parallel or non-parallel, which is twisted. So now we're getting into the axes. Here's a sketch of parallel axes. They can be close to the outside, close to the inside of the spindle. They can be spaced in 90 degree. They can be separated equally or not equally in terms of degrees of separation from each other. The options are limitless. Here's a drawing of twisted axes. Non-parallel axes will intersect either the center axis or any line parallel to that center axis. In this case, these are three axes separated at 120 degrees, and they're twisted at 120 degrees. But these are just two examples of what parallel means and what not parallel or twisted means. Now let's look at some parallel axes outcomes. Here's a spindle that was turned on three axes separated by 120 degrees, and their coves turned on each parallel axis. And here's a drawing of the way that looks: three axes parallel to the center axis. Here's also a parallel axis in an archetype spindle. Here's the center axis. If you put the new axis where the green axis is, then you turn the profile. That's green. And now let's put it on the blue axis, and into the air wood, you turn that profile, which is blue. And the outcome is as you saw it. And these axes are in the same plane with the center axis, separated at 180 degrees from each other. This spindle is different because it has axes that are 180 degrees apart, and then another set that are 90 degrees from there. So each segment is turned at 90 degrees, but they're parallel axes. And here's another example of that. The top part of this was turned on 2 parallel axes, and then the bottom part is turned on 2 parallel axes, but it's twisted at 90 degrees from the top. I hope you're getting to see there's so many options you have for playing around with these ideas. Now, here's a circular type, parallel axes with many axes. I'm not sure how many I put, maybe 4 or 5. And on each axis, I went to the new solid wood and created a cylinder. And here's another idea. There's the center axis, and there's the axis that the off-center one is turned on. This is a circular type as well, with 3 parallel axes. There's the center axis of that. And now we have the non-parallel or the twisted axes. This one is drawn there. It's twisted axes that are twisted at 90 degrees. There are 2 coves, a cove that's turned on each axis. This Spindle is one of my favorites because there's so many objects that can be made from this idea. It's 3 axes that are twisted, separated at 120 degrees and twisted at 120 degrees. There's a drawing of the way that looks. Here is a circular type twisted axes with different ideas on each segment. I think there are also 3 axes twisted at 120 degrees that are separated by 120 degrees. Another idea, just another drawing of the way a twisted axis looks as compared to a parallel axis. They can be in the same plane of the center axis, in which case they cross the center axis, or they can be in different planes. You can have 1 axis on the top and many on the bottom. The options are limitless about where you can place these new axes. So when I was starting really understanding this in 2006, I made smaller spindles and I started organizing them by archetype and circular type, and I started seeing that I had 4 families of spindles. In this family, there are parallel axes and archetype, and I was playing around with lots of different ideas. Underneath it are still archetype, and they're twisted axes. And then to the right, on top, circular, parallel, and below that are circular and twisted. So now we have 4 families, or 4 quadrants of ideas that all have 2 things in common: an axis placement and the type of outcome. There are spindles that have combination of these ideas, but so far I've been talking about just the idea of each spindle. Now you get into the variables, and there's a set of variables that apply to each family of spindles. And I break it down as the anatomy of a spindle. This spindle is made up of the wood, the size and the shape of the wood, the orientation that I'm turning it, the axes and the many places that axis can go, and we just talked about a lot of that, and the profile. And I break the profile into a bead, a cove, a V-cut, a straight line, and these can either be symmetrical or asymmetrical. So with all of these variables being applied to each one of those ideas, there are many, many forms that can be made. So this knowledge offers a pathway to start experimenting in a systematic way and to find some of the many forms that can be made between centers on a lathe using multiple axes. So I always say to people, when you begin, start small and start simple. And you just need to make a few decisions. You need to decide the size and the shape of the wood you're going to use, and I did start with smaller pieces of wood. The type of spindle, whether you're going to turn an arc type or a circular type, the number of new axes and their placement, and go ahead and press those in. So start with simple ideas, and they become the building blocks for future work. This is all you really need to know to begin to systematically explore this area of turning. And I think it is a path to creativity. There's an artist in Richmond, Noah Scalin, and he talks a lot about creativity. Some of the things he says are there. You know, when you hear somebody say, "I don't have a creative bone in my body," it's not a bone. Creativity is more like a muscle, and it needs to be exercised. Creativity is a practice. It's not about perfect and brilliant ideas. It's about showing up every day and making. Now, I'm not saying these ideas are very simple. It does get complicated, and I love this image Wes sent me when he got my book. That's why I wrote a book. It is complicated. There are layers and layers of ideas and things to know and understand as you progress and as you experiment and play. Hope this has been helpful to you, and enjoy. On that parallel axis is I can create a profile just in that air wood, or I can go all the way to the solid wood and create a profile. So I'll do both of those things. Because now you can see that I've gone through the air wood, and now I can create a profile, whether it be a bead or a card. I'll make a little bead. On that solid wood. I've gone through the air wood, and off center I've created a profile on that solid wood, and this is parallel axis. Now I'll just move one end, and the other end is still on that parallel axis, but now it's a twisted axis. And this time I'm just going to create a cove. But I've captured the solid wood, and then I can do anything I want. I did a cove just for simplicity's sake. So now you have a way to think about this. There are 4 families of multi-axis spindles. Archetype, circular type, parallel axis, and twisted axis. So those make 4 quadrants, and those are 4 families. And then there are a million other variables that apply to each quadrant. So that's it.